Alright, so before I start this video tutorial, I want you for a moment just to close your eyes and picture your grade 10 teacher. Picture the day that you first learned about trigonometry and the three trigonometric ratios. You might have even asked the question, are there only three trigonometric ratios? And your grade 10 teacher said, why yes, there are. You probably trusted that person a lot, so you didn't question it. But I'm here to tell you today that your grade 10 teacher was a total liar, and you've been betrayed. But don't worry, I'm here to help mop up the pieces of your broken soul and break the news to you that there are, in fact, more than three trigonometric ratios. So in this video, we're going to talk about three more trigonometric ratios that are called the reciprocal trigonometric ratios. And I'm sorry to break the news to you. All right, so let's talk about reciprocals. So first of all, a reciprocal is an expression that if you multiply by another expression, they have a product of 1. So as it turns out, 4 and 1 over 4, that's a great example of 1 over 4 being a reciprocal of 4. If you multiply these two together, you're going to get 1. Same thing with x and 1 over x. These are reciprocals. Multiply those two together, you'll get 1. So it turns out that these three primary trigonometric ratios that you learned about in grade 10 also have reciprocals. So for instance, sine of x we know is opposite over hypotenuse. That's the ratio of the opposite side in a right triangle to the hypotenuse. If we flip that ratio and call it hypotenuse over opposite, we have a new ratio called cosecant. Okay, so we write that as CSC of x. Same thing with cos. We can flip that ratio of adjacent over hypotenuse. And sorry, this is totally a typo and totally wrong. All right, that should say h over a. Call that secant of x. The tan of x, same thing, flip that ratio and you end up with something called the cotangent of x. A little confusing trying to remember these new labels. Obviously tan goes with cotangent, but one of the things that people get confused about the most is cosecant has cos in it, so why doesn't it go with cos? That's a great question that I am not going to address in this video. However, I will provide you with a quick memory aid that's really awesome and useful for remembering which reciprocal ratios go with which trig ratios. I credit this to a student that was in my grade 11 class when I was in grade 11. This guy showed me this and I never forgot it. I thought it was really awesome, so I thought I'd share it with you. If you write out the word that is associated with each reciprocal ratio, so secant, S-E-C, if you write out secant, the third letter tells you the first letter of the primary trig ratio associated with it. And it works for each one, as long as you remember how to spell each word. If you're not a great speller, it's a tough one. But cosecant, you can see the third letter is S. Sine starts with S, so cosecant is the reciprocal of sine, and that works for all of these. Most people remember cotangent, but some people screw these up. I do this in my own practice every once in a while. You'll see me just like write the word out and underline the third letter. If it helps, don't be afraid to use it. All right, so let's talk about these trig ratios, these new three reciprocal ratios. I'm asking you to state the three primary trig ratios, those are the ones you're familiar with, as well as the three reciprocal trig ratios for an angle of 45 degrees. So 45 degrees, that's part of our special triangle, one of our special triangles. So you can see that you know these, you know how to write out sine, cos, and tan for these ratios. Just look at your, any 45-degree angle will work. Look at opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Now to get these reciprocal ratios, again, cosecant of 45, that's going to be the reciprocal of 1 over root 2. So if we just write root 2 over 1, we can simplify that to root 2. Okay, secant of 45, that's going to be the reciprocal of cos, so 1 over the cos of 45, so we can just flip that and write it as root 2 over 1. Likewise for cotangent, that one's going to stay exactly the same because the reciprocal of 1 is 1. Okay, so that's just a quick little primer for working with these reciprocal ratios. Get used to writing 6 trig ratios. It is a little bit scary at first, but with practice, it's nothing you can't tackle. Okay, same thing, another example here for an angle of 60 degrees. Maybe I won't go over this one in detail. I'll just let you kind of pause the video and see that they, these reciprocal ratios are in fact reciprocals of sine, cos, and tan of 60, just for the sake of time to make this a nice, concise video. All right, so an example here, determine all 6 exact trig ratios for an angle of 150 degrees. Biggest thing here, don't forget that the word exact means you need to not round or write decimal numbers. we want to write an exact answer. The word exact usually tells you to work with a special triangle, but you're thinking, well, there is no special triangle for 150 degrees. Well, conveniently enough, we can use what's called a reference angle and refer to a special angle of 30 degrees. So if I rotate my terminal arm through 150 degrees, there's 30 left until I get to 180. I'm going to use 30 as my reference angle. So I'm going to grab my handy special triangle and I'm going to write out the trig ratios for 150 using a reference angle of 30. Okay, but you got to keep in mind that we are in the second quadrant, right? So in this quadrant, only sine is positive. So we're going to keep that in mind as we work through our trig ratios here. So using a reference angle of 30, I know the sine of 30 would be opposite over hypotenuse, right? So I should have 1 over 2 for my sine of both 150 and our reference angle of 30 is going to be 1 over 2. Looking at cos adjacent over hypotenuse for the 30-degree reference angle normally would be root 3 over 2, which it is in this case, but we have to remember that because we're in the S quadrant, only sine is positive here. Therefore, we just kind of slap a negative in front of our ratio. Likewise, for tan, looking at the 30-degree angle, opposite over adjacent should be 1 over root 3, but because we're in the S quadrant, this guy better be negative. Now, when it comes to writing our reciprocal ratios, remember all we have to do is just flip these. So we can do 1 over 2, which is 2. Right, for secant, same thing, 1 over this ratio. We're going to just flip that ratio and make it negative 2 over root 3. Likewise, for cotangent, we just make that negative root 3, right? So we just flip each of those. Okay, so the last example I want to do here is asking you to determine two angles between 0 degrees and 360 degrees that have a cosecant of negative 2. So cosecant is great, but we don't know a lot about it. So in problems like this, anytime you're working with these reciprocal ratios, it's always just kind of nice to write them in terms of the trig ratios that you're familiar with. In this case, that ratio is sine. Right, so since cosecant is the reciprocal ratio of sine, we can just flip this number. Remember, negative 2 over 1, we just don't write the 1. But if we flip that, we'll end up with negative 1 over 2. Okay, well, this guy, we know how to work with this guy. But remember, the cast rule tells us that since sine is negative, we know that our terminal arm will not be in either of these quadrants, right? So we're trying to come up with two angles between 0 and 360. They're definitely not going to be in between 0 and 180, and that's because our sine ratio is negative. So our goal is to come up with the angle that we're going to be using as a reference angle, right? We know our terminal arm is going to be rotated into either this quadrant or this quadrant, and whatever that angle is going to be greater than 45 or 60 or 30, any of those special angles. So we have to think about a special triangle that we can use and pull out a reference angle from. And as it turns out, we need the triangle that has 1 and 2, since that's the ratio we're working with, 1 over 2. So if you grab your 30, 60, 90 triangle and you look at the angle 30, this particular angle is the angle that has a sine of 1 over 2, right? Sine is opposite over hypotenuse. So that's the angle we're going to pick out. We're going to use 30 degrees as our reference angle. Okay, so I've just drawn the two possible angles that we're going to be working with here. So I've got 30 degrees here, 30 degrees here. My goal is to come up with this angle here, this rotated angle that's past 180 degrees, as well as the angle I've rotated that's not quite 360 degrees. Okay, so I'll just change the color of this one to blue, just for reference. So the blue angle, if I look at this rotation, I know that I've gone 180 degrees and I've gone 30 degrees more. So to find out what that angle is, all I have to do is add 30 to 180. So I know 210 is going to be one of my angles that have a sine of negative 1 over 2 or a cosecant of negative 2. Okay, to get this black angle, I've almost gone 360 degrees, but I'm 30 degrees short. So I'm going to subtract 30 degrees to get 330 degrees. And from that, I can conclude that I've got two angles with a cosecant of negative 2 that are 210 and 330 degrees. Okay, so great example of using the cast rule and our knowledge of reciprocal ratios to determine two angles between 360 degrees that are related. Okay, so that brings me to the end of this tutorial. I'm hoping you're feeling better about, being lied to by your grade 10 teacher, or maybe you had a great grade 10 teacher that told you there are actually 6 trig ratios. Either way, I'm hoping this video helps you as you move on into trig functions. As usual, thanks for watching.